Okay, hello Cloud Gurus, and welcome to this lesson. In this lesson, we're going to look at some of the more advanced features of DynamoDB. And this is really some of my favorite stuff in DynamoDB. And I've got a really cool demo in this lesson to show you too, which I think you'll like. So let's jump right in. So first is DynamoDB Accelerator, or DAX. This is a fully managed, highly available in-memory cache for DynamoDB. It'll give you up to a 10 times performance improvement over using just DynamoDB standalone. This also reduces request time from milliseconds, which is already very fast in DynamoDB, to blazingly fast microseconds, even under load. The cool thing here is that if you're a developer, you don't need to manage any of the caching logic yourself. DAX is completely compatible with existing DynamoDB API calls. So let me show you how this works. Why would you need to cache data when using DynamoDB? With a traditional application and cache, you'd have a cache sitting off to the side from the application. This can be a traditional cache like Redis or Memcached if you're familiar with those. As a developer, you have to code your application specifically to take advantage of that cache, and these can be very expensive, and it's yet another thing to manage. And these caches, they don't typically support writes, just reads. So with DynamoDB, you can get into a situation where you have too many reads and your requests get throttled, meaning you'll get some errors when you try to read from DynamoDB when it's under load. What we can do is introduce DAX into your application. You make no code changes to your application, and DAX sits in between your application and DynamoDB. Unlike those traditional caches, DAX also has what's called a write-through cache. So in addition to just taking advantage of read performance improvement, you can also get write performance improvements. If you send your writes through DAX, they flow directly into DynamoDB, and DAX can respond in microseconds. It's also designed for high availability. So in the event of a failure of one availability zone, it'll fail over to its own replica in another availability zone. And it takes care of all this for you automatically. The next advanced DynamoDB feature I want to talk about are transactions. So what is a transaction? Developers sometimes need to implement business logic that requires multiple all-or-nothing operations across one or more tables. These are particularly common in financial transactions and fulfilling orders in e-commerce systems. So in the case of a financial transaction, you could think of a case where you might want to transfer money from one account to another. You can't debit one account without crediting another account. Both have to happen simultaneously, or nothing can happen. So that's a transaction. Now, under the hood, DynamoDB performs two underlying reads or writes of every item in the transaction, one to prepare the transaction and one to commit the transaction. So when you're thinking about read and write capacity with your DynamoDB tables, keep in mind that you're going to consume more of that capacity when working with transactions. And transactions can operate on up to 25 items or 4 megabytes of data at any time. So now let's talk about on-demand capacity. In contrast to the default provision capacity, on-demand offers simple pay-per-request pricing for read and write requests so that you only pay for what you use, and this makes it really easy to balance your costs and your performance when working with DynamoDB. And when you use on-demand mode, DynamoDB will instantly accommodate your workload as it ramps up or down to any previously observed traffic level. If the traffic hits a new peak, DynamoDB adapts rapidly to accommodate the workload. And what's cool about this is that there's no minimum capacity to purchase. And unlike with provision capacity, with on-demand capacity, there's no read-write charges when the table is idle. You're only charged for storage and backups. Now you might be thinking, this is great, I'm just going to switch all my tables from provision capacity to on-demand and lower my bill. Well, it's not really how it works. You're actually going to pay more per request than with provision capacity. So you might want to use this really for new product launches, where you're not exactly sure what your consumption is going to look like. Once your application reaches a steady state, and you could predict the traffic and the consumption, you'll want to switch from on-demand to provision capacity. So now let's talk about on-demand backup and restore. This lets you create full backups of your tables at any time in either the AWS Management Console or with a single API call. Backup and restore actions execute with zero impact on table performance or availability. So if you come from a traditional relational database background, you might be aware that backup and restore actions typically degrade the performance of those types of databases. You're not going to have that problem with DynamoDB. And backups are consistent within seconds, and they're retained until you delete them. Backup and restore also operates within the same region as the source table. so you can't do backups and restores across regions. Now, complementary to backup and restore, we have point-in-time recovery. This helps you protect your DynamoDB tables from accidental writes or deletes, and you can restore your data to any point in time in the last 35 days. DynamoDB maintains incremental backups of your data. Now, point-in-time recovery is not enabled by default, so you have to go in and turn this on manually. And the latest restorable timestamp is typically 5 minutes in the past. Alright, so now let's talk about streams. This is really cool. So streams are a time-ordered sequence of item-level changes in a DynamoDB table. So this is a representation of what a stream looks like in DynamoDB. Your stream records appear in the same sequence as the item modifications, so you can sort of think of it like a first-in, first-out queue of your data. Your information is stored for a period of 24 hours, and this provides a stream of inserts, updates, and deletes to your DynamoDB table items. So let's talk about the structure of a stream for a second. So a stream consists of stream records. Each stream record represents a single data modification in the DynamoDB table to which the stream belongs. Each stream record is assigned a sequence number, reflecting the order in which the record was published to the stream. And stream records are organized into groups, or shards. A shard acts as a container for multiple stream records, and the shard contains information required for accessing and iterating through these records. The stream records within a shard are removed automatically after 24 hours. Now, there are a number of really interesting use cases where you can apply streams. You could do something like cross-region replication, which is actually something I'm going to show you in the next section, which DynamoDB implements automatically. That's called global tables. You can also establish relationships across tables using streams. It could be used for messaging or notification applications, any kind of aggregation or filtering, analytical reporting, archiving, auditing, and search, and so on. Now, one interesting side effect of streams is that you can combine them with lambda functions to get functionality that behaves a lot like store procedures in traditional relational databases. Really cool stuff. So I just mentioned this a second ago. This is global tables. This is a managed, multi-master, multi-region replication solution for DynamoDB. And this is ideal for globally distributed applications. Now, it's based on DynamoDB streams that we just talked about. And you can use global tables to enable multi-region redundancy for disaster recovery or high availability applications. The cool thing about global tables is that you don't have to rewrite your application at all. It's handled automatically for you by DynamoDB. And the replication latency across regions is typically under 1 second for new items. So I'm going to switch over to the AWS Management Console, and I'm going to give you a demo of how global tables works. Okay, so here we are in the DynamoDB console. You can see on the left, I'm in the Ohio region, US East 2, and on the right, I'm in the Northern California region, US West 1. I want to create a table in the Ohio region and have its data automatically replicated to the Northern California region. This is really easy to set up, and I'll show you how to do it right now. So first, we want to create a new table. We'll call this Replicate Me. Partition key can be anything. We'll just use ID with the default settings. Okay, we'll see our tables being created. This takes just a second. So notice in the Ohio region, we have Replicate Me, but over here in Northern California, it's still empty, no tables. Now, before we set up replication, let's create an item in this source table. Let's create an item here. We'll give it an ID of 1, and we'll give it a new attribute, which is of type string, and we'll call this message, and we'll just say hello. So we have a new table with 1 item, and we want to set up global tables to start replicating data from Ohio to Northern California. So we'll go to Global Tables, and the first thing we need to do with Global Tables is to make sure that DynamoDB streams are enabled. Now, remember from just a few minutes ago when we talked about streams, this is your time-ordered running changelog of items in DynamoDB. Global Tables is going to use the streams in order to replicate data across regions, so we have to enable this. So we'll click Enable Streams. We want both new and old images. This basically just captures the state of an item both before and after it's changed. And click Enable. So now we have streams enabled, and we want to add a region to this global table. So we'll select Add Region, and not every region is available for global tables, but I happen to know that Northern California is one of them, so we'll choose that. It says the region is ready, and we want to click Create Replica to proceed. Okay, so it's setting up our replica, and this does take a few minutes to complete. So I'm going to just keep hitting refresh over here on the right, and in a few minutes, you'll see this new table appear. So through the magic of video editing, I'm just going to speed up time here and hit refresh a few times. Okay, so it's been just a minute here, and you could see over in the Northern California region, our new table Replicate Me is in the creating status. Now again, this does take a few more minutes, so I'm just going to edit out the waiting here, and you should see the status change from creating to active. Okay, so you can see after a rather excruciatingly long time, the status is now active. We could see our initial item has been replicated over. So now let me show you how to create a new item, and you'll see how fast it replicates. Let's create a new item here. We'll give it an ID of 2, and we'll append a new string, Cloud Gurus, and refresh, and it's almost instantaneously replicated. So as you can see, Global Tables is really powerful, super easy to set up, and really fast. All right, let's go back to the lecture. Okay, so that was Global Tables. I hope you enjoyed that. Next, we're going to talk about the Database Migration Service, or DMS. Now, you might have a traditional on-premises relational database, or even a traditional relational database in EC2 or even in RDS. Something like SQL Server, MySQL, Oracle, and so on. And you want to migrate that to a different database, say DynamoDB. So you can use the Database Migration Service, or DMS, to facilitate this migration. So here's how DMS works. On the left, you have your source database, which can be any one of these products, Aurora, Data in S3, IBM DB2, and so on and so on. On the right, you have your target database. Now, this can also be an on-premises database, or one of the AWS managed database services like Aurora or DynamoDB. You can configure all of your data transformation logic inside DMS, and it performs the migration for you automatically. Now, what's really cool about this is that the source database remains completely operational during the migration. Just one thing to keep in mind here is that at the time of this recording, DynamoDB is not a supported source database, but of course we can use it as a target. Okay, so let's talk a bit about security in DynamoDB. All user data in DynamoDB is fully encrypted at rest. DynamoDB encryption at rest provides enhanced security by encrypting all of your data using encryption keys stored in KMS, the key management service. Now, you can secure access to DynamoDB in a number of ways beyond just using encryption. You can use site-to-site VPN, Direct Connect, and you can apply IAM policies and roles to your DynamoDB tables. So if you're an IAM administrator in your account, you can control who can be authenticated, signed in, and authorized, who has permissions, to use your DynamoDB resources. You can also use IAM to manage access permissions and implement security policies for both DynamoDB and DAX. You can also implement what's called fine-grained access. This is where you have an IAM policy that allows users access to only certain attributes within DynamoDB table items. And of course, like many other AWS services, you can monitor your DynamoDB tables using CloudWatch and CloudTrail. You can also use VPC endpoints for DynamoDB to enable EC2 instances in your VPC to use their private IP addresses to access DynamoDB with no exposure to the public internet. Alright, so that's just about everything I want to cover for advanced DynamoDB. If you have any questions, please reach out. If not, please move on to the next lesson. Thanks.